because we don't want to actually mirror these controls. We don't want to actually have to put a mirror on them. Mirroring them would actually put a negative scale value on them in the X, let's say, because we're going across the world X-axis here. And that would invert transform matrices and whatnot, and that is not a good thing. Again, you can read up more about that on my website, but you want to avoid scaling objects, and that means mirroring them across an axis. So what we want to be able to do is do the same thing that the mirror bones does. Mirror bones in the bone tools dialog right here doesn't actually mirror a bone. What it does is it rotates it into place. So we actually mirrored this joint to this joint. And if we look at the local axes of both of these, you can see that what it's done, it's taken the object and rotated it over into place. It's actually mirrored the, in this case, the Z and the X axis, and it hasn't mirrored the Y. It's what's called flipping it, basically, so that you're rotating the object over into place. And what we want to be able to do that is with a control object here. We want to be able to take this control object and have it end up in exactly the same spot on the other side. So what I'm going to do is I'm going to use my listener right now. Actually, let's start with a script. Let's start with a new script. We need a couple of pieces of information here. We need to get the position and rotation of the original. So I'm going to say pause equals $.pause. And that returns the position vector of it. We're going to then get the rotation equals $.rotation. And that returns a quaternion value. And there's those values I'm talking about. You can notice that none of them are high values. That's because that is a vector on that surface of the sphere, and the length of that vector, those first three values, is a value of 1. So it's a normalized or a unit vector, it's called. And then this is the value from 0 to 1 that represents the twist along that vector. Basically, along the length of it, it shows that number. So what we need to do now is because these are vectors in space, they are points in space, we can actually use this and simply flip them over. Rotations are very inaccurate. An Euler rotation is very, very inaccurate, and trying to actually rotate it with Euler angles into the right spot on the other side would be next to impossible to get it right. These are actually position values for all intents and purposes, and it's easy to flip over or make a position value mirrored from one side to the other. So what we're going to do is we're going to take this quaternion value that was added, we're going to say $.rotation equals, we're going to go pick our new object here. We're going to say $.pause equals pause. We're not going to use the rot variable we've created right now. But what I'm going to do is show you how to do this. So I'm just going to take these two and basically mirror them over. This is done by going, the position is done by times -1, 1, 1, 1. So I'm going to multiply the position value by this, and that drops it on the other side perfectly. The rotation, what I'm going to do is, believe it or not, it's this simple. All I'm going to do is take the negative signs out of the Y and the Z values. That'll send it off into space somewhere and then reset the position. You notice I put that next. But if you notice now, it's actually rotated in the opposite spot. It's literally that easy, and it's been rotated over. Now, the method I've used basically will mirror it across that one axis, and it'll flip the X. So you can see the X is currently not mirrored in a sense. If you look at it in world coordinates sense, the X value here, which is the point right there, has been taken all the way over to here. So that's actually not mirrored because it would be here instead. And we don't want that. One of the axes can't be mirrored. The Y and the Z have been mirrored. They've been mirrored over across that center axis to the right spot. And so that's rotating it into place, essentially. Rotating that object over to where you'd expect it to be. So now what we need to do is figure out how to actually work some of this math so that we don't need to go about doing that. Let's do something just dead simple because we know that we're just going to use this simple math. This